Okay, question 2, which is problem 2.32 from your book, edition 10. Okay, so we have a circuit. We have an independent current source. We have a voltage source, which is dependent and depends on the current. So it's basically current controlled voltage source. It is a voltage source, C plus minus shows voltage, the average shows the current. And we have two resistors. Okay, so we basically want to solve this this circuit. The problem specifically asks us to find V0, V0. But then when we are doing that, probably other values or other unknowns also will be solved. Okay, so by looking at this, that's a loop. So we can write a KVL. Okay. So let us start from here and go this way. So plus, you see plus, and also let me write here. I put this current as IO. There's a current going this way, IO. Okay. And I start my KVL from here. This is the start of my KVL. So I see a resistors. Directly, I would put just 2 times IO. Okay, 2 times IO, RI. So I use I apply Ohm's law on that as well. R times I plus. And then I hit the plus again here. The value of this voltage is 2Ix. And then I'm going this way, right? I'm going this way, this way, this way. And then I have to go here. So I see a 6 amp. 6 ohm. But then, because I'm going this way and the current is going that way, I have to put negative Ix. Is equal to 0. Okay. So again, the underlying fact is that if I is going this way, this is plus minus Ix, Vx. And then if I'm going this way, I'm hitting a negative. Okay, let's get current going this side. Okay, hopefully again you can do it automatically. So again, starting from the beginning of the loop, 2 times IO plus 2Ix minus 6 times Ix, because Ix is going, basically, I'm going this way, and the Ix the other. So this is a KVL on this node. And then I can probably also, because it's current source, I can write a KCL here. So Ix, and then IO, and then Ix, and then 45. So basically Ix plus IO minus 45 equal to 0. So 2 unknown and 2 equations. That's good. So let me just let me clear this. So the first equation says 2IO minus 4Ix equal to 0. In other words, 2IO equal to 4Ix. To simplify, so IO is equal to 2Ix. IO equal to 2Ix. This is the first equation simplified. The second equation says IO plus Ix equal to 45. Okay, that's fine. It's very good. So I replace this IO equal to Ix on here instead of IO. Then it becomes Ix plus 2Ix equal to 45. So 3Ix equal to 45, Ix is 15 amp. So if Ix is 15, IO is twice that. So IO is 2 times 15 becomes 30 amp. Okay, going back, you can always double check. So 15 here, 30 there, and then this is 45. So they add up correctly. Okay. So this is Oh, okay. And the problem says what is VO? Okay, good. So we find IX and IO and VO. VO is the voltage across this resistor. It's just R times its current, right? So I can make this smaller a little bit. Okay, good. The VO is RI, right? R times I. R is 2 amp. The IO happened to be 30 amp. 2 ohm, 30 amp, 60 watt. Okay, now look at this voltage, 2 times IX. So IX is 15, so 30 volt is here. So we have 30 volt here. We have, for VO, we have 60 volt there. So just want to clean up a little bit. So this is 30 volt. VO was 2 times IO. Twice 30, so it's 60 volt here. So and then on this one, on the 6 ohm, it's gonna be 90 volt. Because IX is 15, 6 times, so VX is 6 times IX, 6 times 15, which is 9. So everything matches. This is 90. Also 60 plus 30 is 90. Okay, very good. And it says the total power supplied in the circuit. Okay, so we can find the power for all the elements. The ones that are negative, they're supplying the power. The ones that are positive power, they're basically consuming the power. Okay, good. So as far as power, because it only wants us to find the power supply, the one that may be able to generate power, we know that the resistors cannot supply power, only the current source. But you have two current sources. One of them is independent, one of them is dependent. So let's see which one is, if both of them are supplying or one of them is supplying. So let's do the math. So for the P of 45 amp, we can write this way. So if this is the voltage, let's say voltage, which is exactly this voltage 90 times, the current is going that way. So that's why you have to put the negative. So as if negative 45 amp is going this way. 90 times negative 45. Let me do the math. So 90 times negative 45, it's 40, 50 watt. And that was the negative. So it's supplying the power. But also, let's look at the, sorry, I have to write it here. The P of this dependent thing, I call it P of 2ix. the P of these, the power for these. Again, the voltage plus minus 30 volts times the current that is going this way. But what is the current? Let's see. Apparently, we had the IO here, which was, what was the amount of IO? 30 amp. So we had 30 amp going this way, 30 amp. So plus is a plus. And because it's going this direction, times 30, which is 900 watts. And as you see, it's positive. So therefore, even this current source, it's a dependent current source, is actually consuming energy, and that's totally fine. The ones that it depends on the sign, basically. If it's positive, then it's consuming energy, but this one was negative, so it was supplying the energy.